right, I'm just going to wait a minute, waiting to make sure the stream is going to work. Looks like it's working. Okay. So, how you doing? Welcome back. So, I am Mr. Salt, and I am just going over some of these lessons that we've done in class to help those of you who need to get caught up. Okay, that's what this is for. We've already gone over these in class. In fact, the document I'm about to look at, will notice that it's already partially filled out, right? Because we already did this in class. But sometimes when you're in class, the class time is not particularly convenient for maybe some of the distractions that are going on in your learning environment, or perhaps in class things are happening just a little fast and you miss something, or you get left behind. And so here I am. I'm going to do a little video. And the great thing about video is you can pause me anytime, right? It won't hurt my feelings at all, right? You can pause me. I tend to talk a little fast. I recognize that. If you need me to slow down, guess what? Down in like the lower right-hand corner of that YouTube screen, there's like a little settings button. You can actually change the playback speed of a video, and you can set me to like 75% or even 50% if you need. So keep those options in mind. All right, so I'm just gonna go through this, right? I'm just gonna go through this like we did in class. I'm gonna do it not very slowly. I'm gonna go at a kind of a decent clip because we've already done it in class. Because you can slow me down if need be, and you can always pause it, right? Also, alternatively too, you can fast forward it, right? If you've already got what I'm about to go over, you can just fast forward and get to where you need to be to get this assignment done. All right, we want to get these assignments done. We want to get them turned in. We want to get them graded, and we want your first quarter to be something you can be proud of. All right, so this is number 11, I believe. Number 11, who is the outlier? All right, this is the statistics lab. Who is the outlier? The purpose of this lesson was to become familiar with statistical terminology. Here's the math behind the activity. Statistics is a branch of mathematics that deals with the collection, organization, analysis, and interpretation of numerical data. Each day, when you read newspapers or magazines, watch television, listen to the radio, or surf the internet, you are bombarded with numerical information about the national economy, sports, politics, and so on. Interpreting this data is important to your understanding of the world around you. Some often think that the study of statistics is not useful to them on a personal level. But when you work with data that has personal meaning to you, such as heights, student allowances, salary ranges for occupations in which you are interested, or the performance of a favorite athlete, it's easier for you, perhaps, with them to develop an appreciation for the usefulness and power of statistics. C. Data collection. Heights in class. What are your heights in inches? So in class, what we did was we asked you to tell us your height in inches. And here, all these numbers here are the various heights in inches of students in our class. All right, and notice how the data is not yet organized. Yes. So what we did is then we reorganized this data, and we reorganized it from least to greatest. Right. Our smallest number up here was 60. Right. Right there. Person 16 there, and we reorganized this 60 and put that all the way over here as number 1, right? And then we had somebody who was 61. Oh yeah, person number 19 there was 61 inches tall. So we put that there. So we reorganized all this data from least to greatest. The tallest person being 73 inches. That was person number 9 over here. And we then found the mean, all right? So the mean is the sum of all the values in the data set divided by how many values there are in the data set, all right? So the mean is you add them all up and divide by how many there are. In this case, we had the heights for 20 students, right? We had the heights for 20 students. So we're going to add all these numbers up and divide by 20. So it's kind of tedious. I get that. But here we go. 60 plus 61 plus 62 plus 62 plus 62 plus 63 twice, right? 63 plus 63 plus 64, 64 plus 65 plus 66 plus 66 plus 67 plus 67 plus 68. How many? I got two 68s. All right. Plus 68 plus 70. Woo, getting tedious, but I'm sticking with it. Plus 70 plus 70 plus 72 plus 73. All right. I think I've added all these up. I think everything's good. I'm going to press enter. I'm going to get the sum. I'm going to get the total. Sum means add. And my total is 1,249. And I had 20 values here, right? So 1,249 divided by 20, because I have 20 values, should give me the mean. The mean. 62.45, right? And, in class, we calculated a different thing. So either we did it wrong in class, or I did it wrong here. I don't know which, but you can try it yourself and double check my work and see which it is. All right, you can see which one works out. It's possible that in all this data, maybe look at my data, I can find where I went wrong. Right, I'm looking for a number that doesn't look right, and sometimes when you're working with a calculator emulator, you press a button, and when one of the numbers doesn't show up, everything looks good. I'm unclear what happened here, right? So I can just check. There's two 62s. Oh, wait. Here's my, oh, there's 362. Sorry. There's 362s. So that's right. 362s. 263s. Oop. 64. There's 265s. Ah, there's where I goofed, right? There's where I goofed. See how there's only 165 in my data set? Well, there's 265s in this data set. So I goofed here. I'm going to have to add a 65 to this thing. All right? Just goes to show how careful you got to be. So I'm going to add them all up again. Now I've got 1,314. Now if I divide by 20, what happens? 65.7. Is that what we got in class? Yes, it was. 65.7. All right? So there we go. We've reconciled the problem. It was just a data entry problem, and that's very common. That's something you have to look out for. Just be very careful when entering your data. So there is the 1,314 divided by 20, 65.7. That's the mean. That's the average. That's how we find the average. We add everything up, and we divide by how many numbers there are. Okay? There's a very similar word. It sounds like it, but it's a little bit different. Median. Median. Median, I want you to think the middle. All right? Median is the middle value when the values in the data set are arranged in numerical order and the highest and the lowest are eliminated. So, we've got 20 values. Let's imagine I eliminated the 73. All right, let me see if I remember how to do this. There we go. I've crossed out the 73, and then I cross out the 60. So I've crossed out the highest and the lowest. And I'll cross out the next highest, right? Cross that one out. Cross out the next lowest. And I can do this like more than just one at a time, right? I could cross out the next 3 highest, and then cross out the next 3 lowest, right? And then cross out the next 3 highest, and then cross out the next 3 lowest. No, that's not what I wanted to do. I wanted to select that. There we go. Come on. Cross out the next 3 lowest. All right. And since I am near in the middle of my data set, I'm going to cross off this next highest and this next lowest. And lo and behold, look at that. I am left with 2 numbers. I'm left with 2 numbers in the middle of my data set. What do I do if I'm left with 2 numbers? If I was left with just 1, that would be my median. But since I'm left with 2 numbers, I add the 2 of these up and divide by 2 because there's 2 numbers. All right, so to find the median when there's 2 numbers in the middle, you add them up and divide by 2. 65 plus 66 divided by 2 is 65.5. So our median for this data set is 65.5. All right. Mode. Mode is the value that shows up most often in the data set. The value that occurs the most is the mode. All right, the mode. So which value showed up the most? Well, remember that, what was that one? That number that showed up like, what, 3 times? There's a number in there that showed up 3 times. There we go. 62. 62 showed up 3 times. So that's probably our mode, right? Yeah, there it is. 62. It showed up 3 times. That's how I knew it was the mode. No other number appeared that many times. And now range. Range, okay? Range is going to be this a measure of variability or a measure of dispersion. Mean, median, and mode are all what's called measures of central tendency. All right? Mean, median, and mode are measures of central tendency. These give us a measure of where the data is centrally, where it clusters, where it is somewhere in the middle or the average or the mode, right? Measures of central tendency. But range is different. Range isn't about where the data clusters in the middle or center. Range is how dispersed is the data, how spread out is it. And to find the range, you want to remember this thing called max minus min. Okay, you want to remember the range is the maximum number minus the smallest number or the minimum number. Maximum or biggest number minus the smallest or minimum number. All right, our biggest height was 73. Our lowest height was 60, and 73 minus 60 is 13 inches, right? So our range here is 13 inches. The difference between our smallest person and our tallest person is 13 inches. It's only like a foot and 1 inch, right? Difference between the shortest and the tallest. Now we're doing quartiles, okay? So quartiles are related to our median, all right? Quartiles are related to our median. Once you have the median, you can then, the first quartile is going to be the middle value in this first half of the data, and your third quartile is going to be the middle value in your second half of your data, all right? You can envision that. The median is your middle number, and your quartile 1 is the middle number of the first half of your data, and then the middle number of your second half of the data. So let me look at the first half of my data. So I'm just thinking and talking about this data right here, right? So now if I eliminate the highest and lowest, eliminate that 65, eliminate that 60, eliminate that 65, eliminate that 61, get rid of the 63 and the 62. I am left with 62 in the middle, right? If you don't believe me, let me just cross out the top 4 highest, right? I'm going to cross out the top 4 highest. I'm going to cross out the top, oh wait, no, never mind. I'm glad I did this. So what happens if I take away the top 4 and the lowest 4, I end up with 2 numbers in the middle. I end up with 62 and 63, right? So just like median, when I have 2 numbers in the middle, I add them up and divide by 2. The quartile 1 is going to be 62.5. That's what goes in right here, 62.5. Take the 62 and the 63, add them together, divide by 2, you find that first quartile. Upper quartile or third quartile, right? We're going to do the same thing, but for the second half of the data. So just looking at just 11 through 20 here, 66 through 73, all right, we're looking at this data. Take away the 4 highest numbers, right? Take away those. Take away the lowest 4 numbers. Get rid of those, and I'm left with 2 numbers in the middle. They're both 68. So when I add them up and divide by 2, I'm going to get 68. So 68 ends up being the upper quartile, okay? That's the upper quartile. If that seems confusing right now, don't worry. You'll get used to this as you practice it. That's the basics of how we do that. And then there's this interquartile range, IQR, interquartile range. The interquartile range, just like the range was max minus min, remember that? The range was the biggest number minus the smallest number. Interquartile range is going to be the bigger quartile minus the smallest quartile, okay? So 68 minus 62.5, and we have it here. 68 minus 62.5 is 5.5. So our interquartile range is 5.5. Actually, this document that I have right in front of me, you actually have that in your classroom, whether you're in period 3 or period 8. It's these teacher notes, all right? I'm just using the teacher notes to show you what we already went over in class. And this question number 8, do we have any values out there? Or do we have any outliers? No, in this case, we don't have any outliers. What would an outlier look like if we had one? Well, an outlier, if we had one, would look like if we had a number like, say, 45 or 40 in this data set. Or if we had, trying to undo all that. If we had a number high that was really high, like 89 or 90 or 100 or 200, right? If we had somebody who was like 8'5" in this classroom, that person would be an outlier. If you had someone who was like, 4 feet tall or 3 feet tall, that would be an outlier, right? So the idea of an outlier is that it's data that's out there. It's data that lies really, really far outside of the central tendency and even the extremes of your data. It really just pushes things out there. That's the outlier, data that's out there. All right. What's kind of handy is that once you can find the median, once you can find the lower quartile and the upper quartile, and once you know the minimum and the maximum, you can do this thing called a box and whisker plot, or sometimes just a box plot. And this is what a box and whisker plot looks like, right? The box is defined as the lower quartile and the upper quartile with the median in there. That's our box. And then these are the whiskers, this little line with an X at the end, that's the minimum value. The little line over here with an X at the end is the maximum value. And this is like a really quick statistical diagram that can give you some idea of the central tendency and dispersion of a data set, right? You get the median, you get the lower and upper quartiles, and the minimum values. You need five values to figure out in order to draw a box and whisker plot. You need the minimum, you need the lower quartile, the median, the upper quartile, and the maximum value. Okay? Here in class, we'd have you actually draw these box and whisker plots out, but that's a little difficult in this distance learning situation, so we skipped over that for now. We'll eventually figure out how to get that done. All right, so now we're doing shoe sizes. In class, we collected the shoe sizes of students in our class, and these are the numbers we came up with for shoe sizes. This is all numerical data that we collected, right? We reorganized this from least to greatest, all right? And then we added all these up. When we add all these up, we got 190.5. And how many values do we have? We have 23 students, right? You can kind of count them using this upper row right here. 23 students responded with their shoe size. Therefore, we divide the sum, we add them all up and divide by 23 because there are 23 values in our data set, and we got a mean of 8.3, okay? We got a mean of 8.3. We then took a look at the data. Look at the data. We took a look at the median. Look at the median, all right? And to find the median, we had to eliminate the highest and the lowest again. So I'm going to start with the lowest this time. Why not? I'm going to take away I'm going to take away the lowest 5. I'm going to take away the top 5 values. I'm just going to eliminate those. And then I'm going to eliminate the next lowest 4, okay? So here's my next 4 that I'm eliminating. Whoosh. And then let me get rid of 4 on the top end. There's 4 values that are eliminated. All right, now I'm going to move a little more carefully. I'm going to eliminate the lowest and eliminate the highest. And that leaves me with 2 numbers in the middle. Remember what we do when we have 2 numbers in the middle? We add them up and divide by 2, right? So we add 8.5 with 9. And, oh, wait, did I goof this? Let me see. 20. Yes, I did goof this. How did I goof this? There's actually should only be 1 number in the middle, right? There should be 1 number in the middle because I have 23 numbers. Why is that significant? Well, an odd number of numbers should leave 1 in the middle. So somehow I miscounted. I'm moving fast. I'm probably trying to move too fast. There's 5, 6, 7, 8, 9, 10, 11 eliminated from the top. This means I need to eliminate 11 from the bottom. So actually, I need to eliminate even that guy right there, which leaves me, I eliminated 11 from the top. I eliminate 11 from the bottom, which leaves me with 9 in the middle. 9 is my median. 9 is the number that's right in the middle when I eliminate the highest and the lowest until I reach a middle number. Okay, the mode. What number appears the most? Well, 9 appears 4 times. So that's going to be my mode here. Right? I have another 9.5 appears 3 times, but that's not as good as 4. 7 appears 3 times. 9 is the one that shows up 4 times. That's the mode. Range, remember, max minus min. The largest number minus the smallest number, range. Well, the range here was between 11 and 5, right? 11 was our tallest, our biggest shoe size, and 5 was our smallest shoe size. So 11 minus 5 is 6. That's our range. And now we have those pesky little quartiles, right? These things are troublesome sometimes, right? They give us some trouble. We're eventually going to show you a really handy way of determining these with your calculator. But right now, we kind of want you to be able to do it manually so that you understand what the calculator will do for you later as a convenience thing, right? Okay? So 9 is my median. So I'm going to leave 9 is exactly my median. So I'm going to leave 9 out of this calculation, out of this. So I'm just going to take this first half of my data set, and I'm going to eliminate the top 3. Okay? I'm going to eliminate the top 3. And there I go. There's the top 3, and I eliminate the bottom 3. I'm trying to find that first quartile. Okay, I'm going to take away 2 now. Take away 2 from the top. I'm going to take 2 from the bottom. And because this is an odd number of data, I have just one number in the middle, 7. 7 is my first quartile. 7 is my first quartile, or my lower quartile. And that's what I have right there. I'm going to repeat this process for all of the data in the second half, right? I'm going to leave the median out of this. All right. So I'm going to take away my bottom, say 4. Take away the bottom 4. Take away the top 4. And then I'm left with 3 numbers. Get rid of the bottom most number, eliminating the lowest, eliminating the highest. And look at that, I got 9.5. 9.5 is my third or upper quartile. My third quartile or my upper quartile. 9.5 goes in there. And what's the interquartile range of these two numbers? Interquartile range between 9.5 and 7 is 9.5 minus 7. That's 2.5. Pardon me. Okay. So do we have any outliers in this data? Well, let's look. Any number jumps out to us as being, just out there, as being far and away from the others? No. If we had a shoe size of 1, maybe that would be an outlier. If we had a shoe size of 18, maybe that would be an outlier. But pretty much there's a kind of fairly consistent distribution of data, and nothing seems to be crazy, out of place in this data. So no, we don't have any outliers here. And back to our box and whisker plot, which we would have you do if we were in class. All right, number of pets. Our next little experiment in our statistics lab is number of pets, right? So we collected how many pets each student had. We have 21 people who responded to our informal little classroom survey, and we reordered them from least to greatest, right? We reordered them from least to greatest, and we found that the median was, the median was 1, right? Sorry, I keep having to clear my throat. Median was 1. That's 11, right in the middle there, right? We found the first quartile would be, would that be these two numbers here? Yes. If 1 is the middle, then those two numbers are the first quartile. And if 1 is the middle, I take away the highest, take away the highest 4 here, the lowest 4 here. I end up with 3 and 3. So I'm going to have quartile 1 of 0, quartile 3 of 3. So there is our median of 1 right there, our middle value, our lower quartile of 0, and our upper quartile of 3, right? Then the mean is the average. The mean, teacher, takes your average, okay? So we added all these numbers up and divide by how many numbers there are. If I add all these numbers up, I get 31. Don't trust me? You can pause the video and run your calculator yourself, all right? And there are 21 values, right? They're kind of counted by this upper row right here. So 31 divided by 21 is 1.5. I add them all up and divide by how many there are. I've taken the average. I've taken the mean, 1.5. The median, as we've already said, is 1. And the mode, this number repeats the most. Well, look at that. 0 repeats, 9 times. So 0 is definitely our mode here. Our range is our biggest number minus our smallest number. Well, our biggest number is 6. Our smallest number is 0. So our range is going to be 6, right? 6 minus 0. Our interquartile range is going to be our biggest quartile minus our smallest quartile. So 3 minus 0 is 3. Do we have any outliers in this data? No, everything seems, consistently distributed. There's nothing that just jumps out at us as strange or inconsistent with what we've got. Again, you can pause at any time, write down what you need. Everything I'm going over is we went over in class, and you actually have these class notes written away in the Google Classroom, right? This is just me kind of reminding you and re-explaining. So let me just talk about these. I'm going to talk about them. I don't think I'm going to write them, because I don't necessarily want you to copy these answers. I want you to put these kind of in your own words. So first one, are there significant differences between mean, median, and mode? Well, actually, fortunately, you can probably copy and paste the same answer you give for each one of these. No, for all of these, there are really not a lot of significant differences between the mean, median, and mode. So let me go back and let's just compare. Let me go to our first example, scrolling up. So for our first example, that was heights, right? We looked at heights in inches. And our mean was 65, our median was 65.5, and our mode was 62. These are all pretty close to each other, right? Especially the mean and the median, that's really close to each other. And the mode isn't that far off. Let's look at our next thing. That was shoe size, right? Yeah, shoe size. Our mean was 8.3, and our median was 9. That's pretty darn close together. And our mode was 9. Yeah, all three of these measures of central tendency are kind of telling us the same thing, right? And let's go down to pets. The mean was 1.5. The median was 1. That's pretty darn close. The mode was 0. That's interesting. But, all said and told, that's not very far off either. So there we go. In each case, the mean, median, mode really aren't that significantly different. So you can pause this right here and write kind of your best in your own words what we found, right? Just kind of repeating what we just went over. Class height, mean, median, mode is pretty much all the same. Shoe size, mean, median, mode was pretty similar. Number of pets, a little different, but not much. Not much. Which value would best represent the value of the class? So class height, shoe size, number of pets. Most likely, class height and shoe size, it's going to be pretty clearly, it's going to be the mean. It's going to be the best representation of the value of the class. And here's why. When your data is normally distributed, or when your data is evenly distributed, the mean gives you a really good picture of where the data is centrally located. When there are outliers to data, you generally want to think more about using the median, right? When you've got data that's really far out there, when you have outliers, the mean is going to average those outliers in. The mean is going to take those outliers into consideration, and it's going to factor those outliers into your average. So the mean is very much sensitive to outlier data. The median is much less sensitive to outliers, right? Because the median is eliminating them. The median is just getting rid of all that crazy data. So when the data has a lot of outliers, you're going to want to look at the median as the best representation. But when the data is evenly distributed, when it's normally distributed, the mean gives you the best picture of everything, gives you the most granularity, perhaps, one way of saying it. And the mode can give us the best picture when the number that's popping up the most is really, really important for some reason. Like that shoe size thing, with number of pets, that mode of 0, that kind of is important to show that nearly a third or more of the students had 0 pets. So, what is that saying, about why are our students having 0 pets? What, is it? How does our student population compare to other student populations? Maybe we just have an aberrant sample. Maybe this is a more interesting general pattern. So you're going to pause the video here, and you're going to try to best put in your own words kind of a summary of what maybe I just said. You probably want to use mean, class height, shoe size, and maybe even number of pets. However, mode, you might want to use mode for number of pets. Are there any outliers? Nope, there aren't. We didn't find any outliers in any of our pieces. Is that really surprising? Not really. It would be really surprising if someone had 100 pets, right? That would be like, whoa, what kind of pets you got going on? In fact, I think I'm the number 6 with number 6 pets, and it's because I have 4 goldfish, a minnow, and a crayfish, right? Um, so, that was our biggest number for pets, and these are not exactly like real deal pets, right? Um, but yeah, it would be kind of surprising if somebody in our class was 8'9", right? That would be, whoo, oh, wow. Or if someone had a shoe size of 18, jeez, where do you buy those shoes exactly, right? Those would be interesting, differences, and that would be outlier data. But because we don't expect that to happen too often, it's not really surprising there weren't any outliers. Are there any other unexpected data or statistics that are now evident? Um, the only unexpected data for me was the zero mode for pets, right? The fact that so many people had 0 pets. I expected there to be, a number of people with 0 pets, but I figure a lot of people might have a cat or a dog or a goldfish or a hamster or something. Um, so yeah, so you'll pause the video here, and actually that's nearly, oh wait, no, yeah, you'll pause the video and answer that question, and then I'll go on to this number 5 here. All right, for number 5, says now that we've analyzed 3 readily available data collections, state 3 topics that interest you or have personal meaning to you that you would like to analyze further for upcoming lessons and labs. All right, so this is just your own personal preference. What would you like to analyze? Because statistics is maybe a little bit more fun when we're analyzing data about you guys. All right, so that is number 11. We went through the whole thing. I hope these videos are of use to you. Remember, you can pause me at any time. You can slow me down. You can speed me up. You can fast forward. All that good stuff. Just trying to bring you a little instructional support in the asynchronous environment. And maybe you can catch these when your learning environment is a little quieter, a little more peaceful, or maybe at a time where you're a little bit more ready to learn, okay? I'll catch you in class.